Hey guys, I wanted to bring you just a last installment of our calculus tips of the day. And today I wanted to focus on Taylor series. Taylor series is one of those guys that's kind of like, separates us from the ABs for calculus. And it's just, we don't know what the topics are going to be, but this is one of those topics that is different from Calc AB. So there's probably a good chance there's going to be something on Taylor series. And so I wanted to devote a whole tip of the day episode for Taylor series. This is probably not going to be a short tip of the day just because I want to do actually two different free response questions that utilized all different aspects of Taylor series. So let's go ahead and get switched over to the Elmo camera. So you won't see my face till the very end. Wah, wah, wah. I know, that's all right. It's okay. So let's go ahead and switch this. Looks like everything's coming in loud and clear. So our calculus tip of the day is going to be right here for Taylor series. If you need to pause the video, we're actually going to be doing two free response questions, just kind of working them out and doing all the different things for these FRQs. And I want you to try to go find the years of 2013, so 2013, and then also 2015. So these are like the 2 years that I want you to go find. We're actually going to be answering question 6 for both of these. So if you need to pause the video and go find those, please be my guest. But those are the 2 questions that we are going to answer. And so let's get started. I think I'm going to go ahead and start with the one. Oh, no, first of all, I want to just talk about Taylor series in general. So in general, guys, when you talk about a Taylor series, what we really want to talk about a lot is the terms of a Taylor series. So in general, okay, so in general, what does a term of a Taylor series look like? And so basically what happens is there is some sort of a coefficient, and then there's going to be x to a certain power. Okay, this coefficient is always a derivative and then over a factorial. Okay, and then there's going to be x to the power. Sometimes this x ends up being like x minus c to a power, just sort of depending on what the center is. If you are asked to do a Maclaurin polynomial, the center is always at 0, so that's like easy cheesy. The Taylor polynomial, its center is at whatever they tell you. Okay, it is at whatever they tell you. Maybe it's going to be at 0. Sometimes they'll say it's at 0 and they'll be like, okay, great. Sometimes they'll say it's at 2, or they'll say it's at like -3 or whatever it is. Okay, so whatever the center is, that's what you do for the term, right? So each term for the x's. So it may end up just being x to whatever the power is, or it may end up being like x minus 2 to the power. Like it just depends on where the center is. Okay, so in general, we talk about these powers. Okay, in the terms. So the derivative, let's pretend like we're working on like the third term, or the third degree term. So basically what it will be the third derivative at whatever the center is. So if it's 0 or 2 or whatever, okay, over the 3 factorial, and then it will end up being x minus the center to the third power. So these all pieces match, right? Like the power matches, the factorial matches, the derivative matches, unless you're doing something else to it or you have to figure out a pattern. But this is basically how you get a general term for a Taylor polynomial or a Taylor series. Okay, so let's go ahead and look at some specifics here, okay? So we're going to look at the 2013 question first. So this is question number 6. Okay, from 2013, question number 6. So if you can go find that guy, 2013, question 6, we're gonna jam through all these different pieces. Now, I chose these 2 years, 2013 and 2015, just because I felt like they were different in their scopes. There was actually like 3 questions, a part A, a part B, and a part C for each one of them, and they all covered different things. So that's why I chose them. Is there still other questions they can ask? Yes, right? But I thought that this covered like a really good mix of questions. So a couple of things to note about this question. So first of all, it says that it is a Taylor polynomial. Okay, so if it's Taylor, I got to figure out what the center is. And I look a little bit further in the question, and it says it is at 0. Okay, so everything's going to be happening at 0. And so in part A of the question, it asks us to find the it asks us to figure out what the first derivative at 0 is. And you're like, okay, how am I supposed to do that? They told us that f of 0 was equal to 4, and then they gave us something about the first degree Taylor polynomial. That's what this stands for right here. P of 1 is the first degree Taylor polynomial, and it says it's equal to a negative 3. If I'm building a Taylor polynomial, right, the first thing I'm going to do, so if I'm going to be building the first degree polynomial, it means I'm going to need the constant, which is going to be f of 0. Now, why is it 0? Because the center is 0, plus the derivative at 0. And then technically, it's like x to the first over 1 factorial. Now, no one writes x to the first and 1 factorial, right? They just write x because that would be silly. And so here's the deal. I actually know some of this information, and then they're asking me to solve. Okay, they're asking me to solve for this guy right here. So let's fill in what we do know and then try to solve that guy. Okay, it says p sub 1 of x is going to be f of 0 is 4 plus f prime at 0, which I don't know, and then times x. In the question, it gave me this information, that the first polynomial at 1/2 was equal to a negative 3. So I'm going to plug some of that in. The first polynomial at 1/2 would be 4 plus the first derivative at 0 and then times the 1/2. And they're saying that that equals, that's the x, that equals negative 3. So now this is basically what I'm going to solve. I'm going to solve this guy right here, okay? I'm going to solve, it doesn't say 4. It says negative 4. You guys, why didn't you correct me? That's all right. I figured it out. It's a negative 4. So now I'm going to add 4 to the other side, and I'm going to get f prime at 0, which is now multiplied times 1/2, is going to equal a 1. And then I multiply by 2 on both sides, and f prime of 0 is, in fact, equal to 2. Now, the question asked me to show that this was true. All of this work right here that I did, all of this work, that is the shown part. And so I've done it, check mark. I'm good to go with part A of the question. Yay, good job, good job. Okay, let's do part B of the question. So part B of the question now says, okay, they want me to write the third degree polynomial. So this is what this stands for, right? They want me to write the third degree polynomial. So because it's the third degree polynomial, that means I need to write the terms up to I get to an x cubed. And once I get to the x cubed, then I can stop. All right, so let's do this. So the third degree polynomial is going to be like f of 0 plus f prime at 0 times x. I'm going to run out of space. Plus f double prime at 0 over 2 factorial x squared, and then plus f triple prime at 0 over 3 factorial x cubed. So let's see if we can get some of this information. So p sub 3 of x is going to be equal to, f of 0 is a negative 4. F prime of 0, we already figured it out, was a 2. Or, hey guys, this is a little fun little thing. Even if you didn't know what the how to do part A, they gave you what the derivative was, so you would be able to plug it in right here. So even if you messed up part A, it wouldn't matter. So this is 2 times x. Then in the instructions for part B, it says the second derivative at 0 is a negative 2/3. So I'm going to go minus 2/3 over the 2 factorial and then x squared. The third derivative at 0 is a 1/3 over the 3 factorial and then x cubed. Now, if this were the AP exam, you actually could leave it like this. You could be done. Okay. Now, do I want to leave it like this right now? I'm going to have to work with it a little bit later. So I might want to do a little bit of algebraic simplification. So this is going to be a negative 4 plus 2x. This is a 2/3 divided by a 2. The 2 actually can't, the 2's cancel and you get, or it's like becomes 2/6. So this is 1/3 x squared. And then this is a 1/3 and a 3 factorial. So that's a 1/3 divided by a 6. So this is, oh shoot, this is a minus right here. Again, with the messing up, Mrs. Fox. Ay, caramba. Okay, and then this is plus 1/18 and then x cubed. Okay, so this is in fact the answer to this question. And so this is the third degree Taylor polynomial for part B. There it goes. Finish. I know. So nice. Okay, let's do part C. Okay, so part C of the question says now, part C is asking me to, it says there's a function h, okay, and it says that h prime of x is equal to f of 2x. Okay, so now I think they're going to ask me to find h, like find out what h of x is as a third degree polynomial. Okay, but before I can do that, I got to figure out this h prime business. So one of the things we learned about Taylor series, my beautiful darlings, is that you can do like a composite function. So this is saying we're doing f of 2x. So I'm going to rewrite what f of x was, not f prime of x, Mrs. Fox, just f of x. Okay, I'm going to write out a couple of terms of the f of x. So from the first question that the part that we just did, it says it's a negative 4 plus 2 times x. And then it's minus a 1/3 x squared, and then plus a 1/18 x cubed. So if they're saying that h prime of x is f of 2x, that means that every time I see an x, I'm going to put a 2x instead. That's what this means. So we're going to have a negative 4 plus 2 times not x, but 2x minus 1/3 times not x squared, but 2x quantity squared, plus 1/18 times 2x cubed, just like that. Okay, so now this is going to be negative 4 plus 4x. This is going to be a 4x squared, so this is going to be minus 4/3 x squared. And this is going to be an 8 over an 18, which simplifies to be 4/9. So 4/9 x cubed. And now it says that I want us to find h. So all of this was basically to get h prime. Okay, so if I want to get h from h prime, doesn't that mean I need to take its antiderivative? Yeah, it totally does. So I'm going to do, we've learned how to do this. You could do it term by term. Remember, you can do calculus on your series. So I'm going to go term by term, and I'm going to go ahead and take the antiderivative of each of these terms. Okay, so this is going to be a negative 4x. This is going to be antiderivative of 4x is going to be a 2x squared. The antiderivative here is going to be an x cubed. I would have to counteract that cubed by multiplying by 1/3. So this is going to be 4/9. And then this one is going to be, let's see, the antiderivative of this is going to be, let's think, it's going to be an x to the 4. Wait a second. Guess what, guys? I don't even need to take this guy's antiderivative. What? What is happening right here? Why don't I need to take it? It said when I did h that they only wanted the third degree polynomial, which means I need to stop at the x cubed. Ta-da! I don't even need any more. But you know what I do need? I need a plus c. Folks, we don't know what the constant is, so you have to put plus c. You will notice in the rest of part C of the question, there was this part that says h of 0 is equal to 7. Ladies and gentlemen, a fun fact about these AP questions, they never give you anything that you're not supposed to use. So because they told us this, we got to use it, and so now we're going to figure this out. So I'm going to go ahead and do h of 0, which means every time I see the x, I'm going to get a 0, so it's 0 plus 0 minus 0. Plus c, and that's supposed to equal 7. So c is equal to 7. So here's what h of x is as a third degree Taylor polynomial. It's going to be the constant of 7 and then minus 4x plus 2x squared minus 4/9 x cubed. And that is your answer for part C. Just like that. Yay! Isn't that beautiful? Okay, so look what very, very, very fun things we had when we were solving this, guy. So lots of fun things to work for, different types of questions, and hopefully that doesn't look too intimidating as you were doing it, okay? All right, so let's go on to another type of question with some other things for Taylor polynomials, okay? And now we're going to look at at 2015. Okay, so go ahead and find, fish out 2015. So let me switch my paper, shuffle, shuffle, shuffle. And let's go to 2015. Again, we're going to look at question 6. Okay, on the real AP exam, they always make question 6 be a Taylor polynomial. And so that's always like a good one to look at. So if you want to look at other Taylor series questions or Taylor polynomial questions, you should go look at all the question 6s. Usually that's the one. Okay, so in this question right here, they've given us a summation already. So this is already starting out a little bit differently. The summation that they're giving us says it's n equals 1 to infinity of negative 3 to the n minus 1, and then over n, and then x x to the n power. Now, they wrote out a couple of terms. I'm just going to keep that there for ourselves. In part A of the question, it asks us to use the ratio test. I love the ratio test. It is one of my favoriteest tests. It's so beautiful. Okay, the ratio test to find R, and R is the radius of convergence. Okay, another thing I want to note about this is it says it's a Maclaurin series. Okay, I would have guessed that by just looking at this guy right here because it doesn't say like X minus a number, but just remember that the center for a Maclaurin is equal to 0. Okay, so just another little fun fact for us to practice there. The ratio test does give us the interval of convergence. It's supposed to be the limit as n approaches infinity. You take the absolute value of the nth plus 1 term divided by the nth term. I know, it is a pretty fancy little cute formula. So what we're going to do on this one is we're just, instead of dividing by the nth term, we're going to multiply by its reciprocal. So because there's a fraction here, so the nth plus 1 term is going to look like this. We're going to do a negative 3 to the n minus 1 plus 1 term. We're going to have x to the n plus 1, and then that's going to be divided by an n plus 1. So there's my n plus 1 term, and now we're going to multiply by the reciprocal of the nth term. So that's an x to the n, a negative 3 to the n minus 1, and then just an x. Nope. And then this is not x to the n right there. Seriously, Mrs. Fox, what did you write down? This is an n on top. I was totally kidding. This is an x to the n right there. Now, algebraically, I guess I can't really talk and write at the same time, or maybe it's just hot on my patio. I do not know. Oh my goodness, I have heat stroke. Okay, I'm back. Okay, so now we're going to cancel some things algebraically. So one of the things is that this x to the n is going to cancel with all of these, and there's just going to be an x left. This negative 3 to the n minus 1 power is going to cancel with all but one of these, so all of these are going to go away, and we have a negative 3 on top. And then we just have an n and an n plus 1 left over. So this is now going to be the limit as n approaches infinity of the absolute value of a negative 3, an x, and then we have an n over an n plus 1. Now, I kind of separated that out because I just want to look at that by itself. This is as n approaches infinity. As n approaches infinity, this guy right here, because this is a first degree and that's a first degree, we take their coefficients. This turns into a 1. So now all we have is an absolute value of negative 3x, okay? Because the n has already been replaced with the infinity. That's all that's left over. I think what I'm going to do is I'm going to separate this to be like the absolute value of negative 3 is a 3, and then the absolute value of x. And for the ratio test to work, we want it to be less than 1. That's what makes things converge, okay, is when it is less than 1. Now, this is not asking me to find the interval of convergence. It's just asking me to find the radius of convergence. If it asked me to find the interval of convergence, I would have to check some endpoints, but I'm just going to do just this part right here. I'm going to do the sandwich on this. So we're going to go 3 absolute, nope, not the absolute value anymore. Just kidding. We're going to go 3x, and then we're going to go to the sandwich. So we're going to put a 1 and a negative 1 just like that. And when I divide everything by 3, divide by 3, divide by 3, divide by 3, I get that x is in between a 1/3 and a negative 1/3. Now remember, up here we said the center was 0. So if the center is at 0 and my interval, like it goes from a negative 1/3 to a positive 1/3, that means that my radius of convergence is going to be 1/3. If I was going to find the actual interval of convergence instead of the radius of convergence, then I would have to like check the endpoints by plugging the x value back in, but that's not what they asked me to do. They just said, what is the radius? Boom, I'm done. Have a nice day. Yay! Okay, that was a fun little ratio test. Okay, let's now go to part B of the question. So part B of the question says, find the first 4 non-zero terms for f prime. And then it has another question. Okay, so we want to find f prime, the first 4 non-zero terms. Got it. Okay, I think that what that means is maybe I should start with f, write out some of those terms, and then figure out how to do the f prime. Okay, so the f, it says I'm going to write out some of the terms. So I'm going to write an x, then I'm going to write a negative 3/2 x squared. Where am I getting this from? The question, right? That's all I'm getting it from. It's just from the question. So x minus 3/2 x squared plus a 3x cubed. So here's the deal. If I'm going to take the derivative of these, like term by term, it says I need the first 4 terms. I only have 3 terms right now. I'm going to need another term here. So how am I going to get the next term? I'm going to go ahead and plug, let's see, the first term, second term, third term. I'm going to plug in the 4th term right here and figure out what this is. So this is going to be a negative 3 to the 4 minus 1. So that would be the 3rd power. So that's going to be a negative 27 over 4, because that's n, and then x to the 4th. So these are 4 terms of the function f, and now it asks me to find f prime. So as we did with our previous question, you can just do it like term by term. So I'm going to take the derivatives term by term. So term by term, this is a 1. This is going to be a negative 3x. This is going to be a 9x squared. And this is going to be a negative 27 x to the 3rd. And lo and behold, that is your answer to the first part of part B. Now, there's another question, and you're like, what does this even mean? It says express this derivative as a rational function. A rational function? What does this even mean? Like, I'm so confused. Okay, so I'm just going to stare at this for a while, and I know you can't see my eyeballs, but I am totally staring at this guy. And I look to myself, and I'm like, well, that's kind of interesting. Do you know what this looks like to me? It looks like that every time we go to a new term, they're kind of like multiplying by the same thing. It looks like every time they do it, we're like multiplying by a negative 3x. Wait a minute, I'm having a revelation. Folks, if you multiply by the same thing every single time, it means that it's geometric. Hey guys, little action. There's a fire station by my house, so the fire truck is going by. Bye, guys. Everything's going to be okay. Get there safely. Okay, so this is a geometric series. Now, back in the day, and actually in class, we learned that if you have an infinite geometric series, you can rewrite that. A geometric sum is the first term over 1 minus the common ratio, as long as that common ratio is less than 1. By finding the interval of convergence, we know the values that are going to make this be less than 1, okay? And so basically, I'm just going to take the first term and then the common ratio and slap it together. So this sum is going to be the first term, which is a 1, and then the common ratio of negative 3x, so 1 minus a negative 3x, that becomes a plus, and then we get, for our answer, 1 over 1 plus 3x. Isn't that interesting? Okay, so we're putting together all of our knowledge. I know, so amazing. It's just kind of like a really cool and great question. All right, we're now going to venture off to part C. Okay, so part C of the question says, let's see what part C says. Dun, 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 dun. Okay, part C says the first thing it asks us to find is the first 4 non-zero terms for e to the x. Okay, so e to the x, guys, if this were the real test, you would have to like get that from your memory, but you could just get this from a piece of paper. Maybe the very colorful stuff you must know cold paper, or your, I don't know, just somewhere you're going to get this. And so e to the x is actually, I do have this memorized. It's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, technically plus dot, 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 but it asks me for the first 4 terms. And so this is part of my answer. Okay. The next thing it asks me to do is to find a product. Okay. It says that g of x is equal to e to the x times f of x. So one of the things that we did in class, and I know we did an example like this back in the day, is that we took like a series and multiplied it times another series and then tried to figure out what that would be. That's exactly what we're going to do. We're going to be doing a massive like distributing question. Oh, some more sirens. Can you guys hear those? Can you hear them? Can you hear them? Let's just wait. Go forth. Save them. Save them. There's always something happening when I try to do a video, you guys. Like, seriously, never a dull moment over here at the Foxes. Okay, so here we go. We're going to actually make a giant distribution question. So we're going to say that g of x is equal to, we're going to take the e to the x. We're going to go 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. And we're going to multiply it times the f of x. The f of x is x minus, I'm getting this straight from the top of the question, guys, 3/2 x squared plus 3x cubed plus dot, dot, dot. Okay. The question is specifically asking me to find, let me read it. Use this to write the third degree polynomial. Okay, so the third degree means that I need to do everything up to the x cubed. Once I get the x cubes, then I can stop. Okay, this is going to be one ginormous distributing question. Where's some colored markers? Here we go. Okay, so I'm just going to distribute. I'm going to take this one and I'm going to go distribute to all three of these terms. So here I go. 1 times x is x. This is what g of x is equal to. 1 times the, so it'd be negative 3 halves x squared. 1 to the next term would be 3x cubed. Now I could go some more, but I don't have to because I get to stop at the x cubed. Whoop, whoop. Good job, me. Okay, so now I'm going to do some more multiplying. So this x is going to be multiplied 1, 2, however many times I need to make it, right? So this is going to be x times x is x squared. And I'm going to put it underneath the x squared just so it's easier for me to add these babies up. And then x times 3x, x times 3 halves x squared is going to be minus 3 halves x cubed, and I get to stop. Okay, then I'm going to do the last one. So I'm going to take this guy and multiply as many times as I need to. So x squared over basically 2 times x is an x cubed over 2, and I get to stop. Folks, I'm going to add all of these up. Okay, I'm just going to have to add it up over here because I ran out of space. I know, so silly. Okay, so adding them up, just an x. Got it? This is negative 3 halves and a positive 1. So that'd be 2 halves. That'd be negative 1 half x squared. And then this is, okay, I think I need to do some halves. So this is 3 halves. So 6 halves minus 3 halves is 3 halves. 3 halves and 1 half is 4 halves. So that would be a 2. So this is 2x cubed. And ladies and gentlemen, those are the first, that is the third degree polynomial for g of x, where we have to multiply those two series together. That's it, guys. Nice work. Nice work. We did it. We did it. Okay, so what I'm going to do is I'm going to switch back to the camera just so I can send us on our way. Okay, so we just did a couple of Taylor series questions. I really hope that those were helpful. We covered all different kinds of things. Did we cover everything? No, right? Because there's lots of things that they can do. So keep on checking on those question 6s. They have really good stuff. And hopefully this video was helpful. I think that's it. I hope you guys have a wonderful day. And I will see you later. Bye. Adios.